All right, ladies and germs, boys and men, women and children, and other people that have wondered why I haven't done any of these in about 4 months. All 10 of you, but I'm back at it now, I guess. I'm trying to make time to do things, so this is one of those things that I'm making time to do. Anyway, a couple of changes, very small, before I get back into this. The box source file here, I put a couple more, options, parameters in here, if you will. Display library, I did SDL. I tried it with the full screen option and it was being buggy, so I got rid of that. But SDL, we got that. I gave it megs1. This is how much memory it's going to emulate for the host and the guest machine at once. I'm just doing 1 meg, but I'm going to start 16-bit CPM, just go off there. And that had, 1 megabyte of RAM, I think was the original IBM PC, the max it could do, something like that. Anyway, we're still booting from A, still got everything else, emulating 1.44 meg floppy and all that. So the other thing is I put this into commitment control, not commitment control, that's not my work. Put this into change management, just checking it with git status so I can make this open source. I'm still considering what, platform I'll do for that, GitHub, GitLab, whatever. If you have a preferable one, let me know, but I'll probably put it up there just to put my stuff towards, at least as a private repo, if not public. But that's about all I did. I think I messed with the boot sector a little bit, which I don't have open here, which is good. I put the file table, I think, is the second thing in the disk. So let's see, read this into memory first. So I moved the kernel to the second sector on the disk. I had the boot sector, the kernel, and then the file table. Why? I don't know, but that's what I did. So the file table is now at sector 5. And our boot sector is at sector 2, going 3 sectors. So I changed this to 2, this to 3, and then the file table I had to change that to 5. So boot sector takes up the first sector, the kernel takes up the next 3, so the file table would be 5 from that point. And then there's calculator, which I'm probably going to get rid of soon or change. But anyway, those are the only changes I made. This still works. This opens up. I'm just kidding, it doesn't work at all. All right, there we go. You have to actually be in the bin folder if you want to run it. And then it goes over here and everything, but it still works. Can't use the mouse. I tried to do full screen and resizing. Like if I do full screen, it looks weird like that because I'm in OpenBSD and everything, but that doesn't work. But everything else does, graphics test still works. The file thing, which I'm going to change the file thing. Actually, reboot. And print registers. This is very slow, but I get a higher IPS with SDL. It looks slightly different, but you get a fair bit more IPS. If I was doing the regular X display library, which is the default, is giving me like low 40s for that. But anyway, everything still loads. We're still good to go. So today I'm going to try to make a little bit of change to the file table. I took notes so I could get my thoughts together before this and be a little more coherent as I ramble on endlessly. But I got notes here, paper notes, and pencil even, which looks better like that. So I got a little more robust file system thing I'm gonna go with, and then I'll try to make a prompt. Like here we have the, not a VM $. If we call that a prompt, then I'm gonna try to make like a prompt thing that takes in commands. But anyway, let's work on the file table. Let's look at that, work on that. Let's go back to source here, assembly, file table. So I am thinking about going with not FAT, file allocation table, like Microsoft, maybe more like a mix between that and CPM, which I was reading a lot about different operating systems and older ones. CPM being, I think, control program for macros, control program for microprocessors. But it had, its own sort of archaic way of handling file system things. And I figure I'd do something kind of like that because I'm still going to do 16-bit for the time being. So what I'm thinking of doing is 16-byte entries in here. So I'm not going to have, the brackets and all this. It's not really going to look like this. It'll look a little bit different. All right. So I'm going to do 10-byte names to start off. I'll probably increase this later, but I wanted to keep it small and easy to manage to start off, which is still, I think CPM's original limit was like 8 character names or maybe even 6. So we're going to do 10, which is pretty nice. So the first 10 will be the file name, and then Bytes 10 through 12 are going to be the file extension or the file type. I'm going to put extension. So it can be, you know, like .text, .exe, etc. It'll be like this. I won't have the dot. I won't include the dot. It'll be kind of implicit or implied. It'll be an implied dot, but you know, the file extension, file type that it is. .txt meaning, in this case, plain ASCII text, not Unicode or EBCDIC or anything. Byte 13, I'm gonna be doing, this is where the weirdness comes in because I'm not sure what I really wanted to do. So byte 13 is gonna be our sort of directory entry into our file table entry. And what this is gonna be is usually it's gonna be 0. So I'm gonna do, let's do starts at 0. And then I'm probably going to do all these in hex. So we'll do start at 0 hex. And then if a file takes more than the amount of space for one entry and you need to point to the next or you need to figure out where else it is, then we're going to increase this number. So this isn't the most efficient file table that there is because I'm going to have basically duplicate entries. If something overruns the space for one, it's going to be the exact same thing, but the directory entry will be increased and the other values might be different. Do number of file table entries. Maybe I'll know what I meant by that later. Okay, but anyway, byte 14. This is going to be the starting sector that the file is in, or at least that this directory entry for it is in. So, i.e., it starts in sector 6.6. I don't know. 6H would be start in sector 6. All right, and then the last byte, the 16th byte, or byte 15, is going to be the size of the file. So we'll put file size, but this will be in sectors, in hex digit sectors. So I'll be able to hold more, and we can fit them in. So this could be, you know, a range 00 hex to FF, or 0 to 255. So, and these are 512 byte sectors that I'm still going with. 512 byte sectors. So the max file size for one of these entries is going to be 255 times 512, pretty much, which is, I don't know that off the top of my head. So that is 130,560 bytes. 13560 bytes, or that is divided by 1024, 127 and a half kilobytes. So I think that's a pretty good size for stuff to start off with, unless they start doing advanced graphics things or something that takes up a buttload of memory or something. Is that kilobytes? Is that what is that the regular scientific thing? You gotta put the little I there to make sure it's 1024. I'll just do kilobyte, I don't care. 127 kilobytes, 127 and a half. So if a file overruns 127 and a half kilobytes and I have something to, you know, take care of that and write another entry, then the next one for that file, these will be the same, and then but the directory entry would be increased to 1 if the previous one was 0. So, and then that'll allow it to go up to like 255 kilobytes, and if it runs over that, the directory entry would be 2, so on and so forth. So they could be a max size of, you know, 255 512 byte sectors multiplied by 255 directory entries. So 32,512 kilobytes, that's not bad. We divide it again by, I don't know if you divide by 1024 again or 1,000. Let's just do 1,000. So 32 megs would be my maximum size for a program in this file table. 32 megs, not too bad. So I don't think that's too bad, but these are going to be our entries in here. I'm going to get rid of this text because we're not using that text anymore. Haha. What we are going to do is move this stuff forward, and I'm going to also put our current, whatever we currently have that we're making a binary, I guess I'm going to put in here. Like I'll put the boot sector file as an entry into here, and the kernel as an entry into here, because then we can later read from them and then modify this thing with itself. We'll have a wonderful time messing everything up, and it'll be great. It'll be just great. Let's just make a little separator here. A little separator. I'm very bad at making ASCII tables. As you can tell, that is okay. this is how we're going to be. So instead of doing this thing all here, all this little thing all here, we will have to change our menu F to read from this, but I'm going to use, you know, this file table thing to fill our stuff out. So I guess the first thing I'm going to enter in is the boot sector. Let's open up. Let's review the make file. I'm going to put the boot sector in because that's the first sector currently that we're making into our OS, you know, binary file. So I'm going to include that as the first thing. So byte 0 to 9 are going to be, you know, the file name. It's boot sect. That's byte 0 to 9. Although I'm going to probably pad these out with nulls just to make it easier on me later. So 1, 2, 3, 4, 5, 6, 7, 8. So I need 9. Probably just be a 0, wouldn't it? Yeah, 9, 10. Or 9, 10. I'm not sure the best way to do this. We'll just do this. So that's byte 0 through 9, effectively. Then byte 10 to 12 will be the file extension. This is going to be .bin.exe. It's executable. You can run the code. Let's just call it a bin. We'll just call it a bin. Why not? Might as well. That's what I'm already calling it now. Directory entry is going to be 0 again. Call it 0h. It doesn't really matter. And then the starting sector, it's going to start in sector 1. I guess, are we doing 1 based or 0 based? I don't remember, because it's been a while since I've done this stuff. If we're going to read from the boot sector, starting sector to read 5, 1 based, 1 based. This will be sector 1. So I'll do 1 hex. Okay, and 15, the file size in sectors would also be 1. It just takes up 1 sector. So that is our boot sector. All right. I forget what the line continuation character looks like, but it's at the bottom of the kernel. So we can always do that, which is just a backslash. That's not bad. Just do a backslash. There we go. That's okay. So that's our boot sector. So what we can then do is include our next file that we're doing. Go back to the make file. So the next thing I put in was the kernel, so we can put the kernel in here. It'll be kernel, which is 1, 2, 3, 4, 5, 6. So I can pad it out with 7, 8, 9, 10. This will also be a bin. Its directory entry 0. Its starting sector is in 2, and its file size is 3. So I'll do 2 and 3 hex. Which I don't know if it'd be easier to go like 0, 1, 0. I don't know. We'll just do this. If this doesn't work, we'll do something else. And then after that, we have this file table, which we're putting into memory, referring to itself. Good stuff. Which it'll be technically a binary. We can just, but if we say it's a text file and we read from it acting like it's ASCII characters, it should display our characters we have here. And then the other garbage like these. But we should be able to read, you know, the stuff where we put in characters. That's what I'm going with right now. I'm going to say this is a text file. We'll see how we deal with that later, because it's got weird hex values in there. But let's just say it's a text file. It's fine. So these are what we have, and then I guess we'll pad this out. The only thing is we'll have to find where the end of this is, which I guess will be, well, it'll be all these zeros, I guess, but we'll have to find where the end is when we go to write. If we want to add more stuff to this, to the file table, we'll have to somehow get the end, but we'll figure that out later. I think it'll be relatively easy since I'm making these 16 bytes in length. I just read, 16 byte. Is there a name here? Yes, go 16. Is there a name here? Yes, go 16 bytes. Is there a name? And then after we do this, it'll be, there's no name and we can write to it. Maybe I'll say that's, for now, we'll go with that being the idea of, hey, this sector has not been allocated. It's not been, written to, so we're going to use this. As long as it isn't in one of these sectors, it has to be after. But there's other considerations for that I have to think about as well. Like, do we want to reshuffle all these? What if we move stuff around? Do we want to implement moving stuff and copying? Because then I have to, do some calculations here and make sure stuff doesn't overwrite anything, make sure data is protected and all that. But we'll just do this right now. Let's go ahead and change, before I get to do the prompt, let's go ahead and try and change the kernel. Let's go ahead and change the kernel, because what I think is going to happen is I'm not sure this is going to compile. I guess maybe I can try that. It might compile, or it might assemble rather. Oh no, it did. Does this still run? You know what I need to do is make sure that that doesn't... Okay, it still runs. We're good. We just rename... Well, the file table doesn't work, which is what I thought. That's what I wanted to test. Just making sure. Okay. For those of you guys that are running... I am in bin. Yeah, for those of you guys that are running box and you're trying this out, if you pass a Q and the flag -Q, it will prevent the menu popping up and it'll just run as if you did a 6 to start simulation. It'll just run. So if you're tired of doing that, you can pass a Q flag to it. If you don't like doing this in a 6, you can do a Q flag. But anyway, yeah, let's go back to the kernel. Yes. Let's go back to where we're printing everything out. All the way up here. File browser, yep. Our thing we spent so much time on. We get to change again. How wonderful. That's okay. So I'm assuming we're still going to load this to memory location 1000 though, right? We still want to do that? Yes. So we are reading it into memory at location 1000. That's what I thought. All right. I'm just making sure. I got to refamiliarize myself with the literally just 3 files that we have because I haven't done this in so long, but that's okay. I did read stuff and do notes. So we reset the text screen. That's fine. Get the file table heading. Sure. Print string. We're probably going to change the file table heading because it's file program and it's sector. Probably going to change this to look more like this thing here. So let's go ahead and maybe set that off to begin with. Why is this blue? I don't want that to be blue. There we go. Those are the headings, which is what we want. And a 0. So I'm going to have to write this thing out horizontally. Is what I'm going to start with. Maybe we'll change it later to vertically. I don't know. We'll do horizontally just to begin with, though. What are we going to check? I guess we're just going to see if it's not a 0, because that would mean there is a name. I'm going to have the names, I guess, be like left justified and then padded with 0s on the right, with nulls on the right. So assuming there's a name here, and the first byte of the 16 bytes we're doing, right, so bx would be 0. So would that not point to this automatically, though? That should point to that automatically. Let's change the ANSI term again. So let's see what we have in here. If the stuff's actually read as ASCII. It's stored as ASCII. Here we go. Kernel booted. Kernel code. Boot sect. Kernel. File table. Calculator. The text stuff is stored as text. The other stuff isn't. That's okay. That's all I wanted to check. Just double checking, making sure. Alright, so let's go back into here. So we don't need to increment to start off. We're already pointing at the 0th element, which should be this B, I'm hoping. So I guess we can check if our byte that we're on is a null or not, if it's a B or not. So I do want to move this into AL first off, but we shouldn't need this, I'm hoping. So we're going to compare it to a 0. So this is if they're searching though, isn't it? Is this if they're searching for the name? Not yet. This is just where we're printing everything out the screen. This is where they go to get the program name. They go down here. We're going to have to change this a lot. This is going to be fun. Not really. I spent so much time on this too. That's okay. This will be better, more robust for the future. Basically, if this is 0, we're going to end, right? So where does this end? It's down here, file table underscore end. This is where it ends. Let's copy that. All right, if we are at a null, let's jump. Cannot type anymore, which is awesome. We'll just go back. Is file name null, add into file table? If so, stop reading file table. Okay. But if not, then we can print out this screen, I guess. Since we already printed the heading, we can print our stuff out to screen. Up to the 9th byte. So how do we might need to keep a track of what byte we're on out of 16, right? We might need a counter like CX for characters and file program name. Might need a counter there, which good thing we already zeroed it out up here. Instead of number of characters, let's change this to number of bytes in at current. File table entry. Alright, so we have AL. What we can do is print it to screen. So we'll print byte 0 to 9 to screen. So let's not call this file table loop. I will call this file entry. loop or something. I need like an inner loop here though, annoyingly. All right, file name loop. And we go to the next file table loop. Okay, well, no, not really. We can name the front. I don't know what I'm doing. I'll splice this together later. It'll be great. Let's just call this file name loop. Go to the first character, what we're assuming be the first character. We do this, jump file table end, all right. But if not, we need to print it out to screen, which is AH was 0x0E before, so we don't need to worry about that at the moment, I don't think. So that's good. We can do int 10, which will print the character to screen. All right, or we can call our print string. If we move the whole file name string into SI, we could print it to screen, but I'm not sure if I want to do that. So when it reaches null, we'll go to, I don't know, file name end, depends. Yeah, we'll do that. We'll make a thing called file name end, stop reading, file name. All right, otherwise we're gonna print it to screen, and we'll go back again. All right. So keep printing the whole name to screen. All right, and this will be file name end. And what this will do is read the next thing, which is the extension. Actually, let's go this, jump file extension. Maybe I don't need a counter for the number of bytes if we just do this. We're assuming they're in there correctly. We might need to make this more robust later, but that's okay. We'll do file extension, why not? All right. However, when we get here, we need to, if the name is padded out with zeros, we need to skip over those zeros. So compare AL to null again. If it is null, it goes to the file extension. So we need to increment. I'm not incrementing BX here yet. I need to do that. All right, increment BX, there we go. Then go and get the next one. Okay, so file extension. So assuming we're still zero padding here. If it is zero, we need to increment again. I don't need to do all this. I don't think. I hope not. Oh, I need to go skip over the zero padding, I guess. So how do we do that? We need to compare again. What if it's not? What if it reads all of calculator? Then it needs to read bin. It'll read that immediately. So what I need to do is compare CX. I need to increment CX as well. I do need to keep track. All right. Here's CX to 10. Starts at 0. Well, 9. Starts at 0, goes to 9. At end of max, file name length. All right. If it is 9, then jump to print. This one will be file extension. Instead of this being file extension, let's name this something else. Let's name this name padding or something. Check name. That sounds better. So stop reading goes. So check name, compare it to 9. If it is, we'll go to file extension. If we're not at 9 yet, then we're gonna increment CX because it's just been padded with nulls. And go to check name. So hopefully stuff's been input with names right, but anyway. File extension, all right. So here we should have the characters that are, you know, after this is 9, this will start 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're good. And we go to file extension. Well, we need to increment BX as well whenever we do this. To skip over those characters in the file table. So we should be at the extension, which for this is bin, for the other ones is text. I guess what we also need to do is print out white space until we get to the other things down here. I haven't been looking at that. We'll do that in a bit. Let's just print these out to begin with, because that's easier to reason about. So let's do that to begin with. So again, we'll move into AL. At this point, what's in ESBX? So this should be the file extension name. Which is, I'm going to assume, is always going to be 3 characters in length. So what I'm going to do is XOR CX again with itself to zero it out. Oh, maybe I won't. I can just print out 3 characters. It's fine. We'll do It'd be easier to just print them out. So AH should still be, oh, just to make sure. We'll keep this back to 0x0e. And we'll print out the characters. Ints 10. Alright, increment bx. And then move. Yeah, motion clip outside my door. Nice. Move AL, because the neighbor was driving by. 10. Increment bx. Move AL. I am going to change this later, hopefully, to not do this, because this is not good coding, but that's okay. Say we printed out the extension. Okay. Then after that, we'll get directory entry. So we'll put directory entry, I don't know, or directory entry number. Directory entry number. So this I'm going to convert to ASCII because this is a regular hex value that I'm going to have here. So I want to convert this to ASCII to print it to the screen. So let's increment bx again and move it into AL. Instead of printing it out, because it won't print out, it'll be null. We don't want to do that. We want to convert hexadecimal, which we have, right? Don't we have print hex? But to be able to convert that, we need to do whatever we did in print hex, or just call print hex, I guess. We could do that, because a hex digit is a nibble, so that's 4 bits. So 2 hex digits should be 1 byte, which is an AL. AL is only 1 byte. So I should be able to AND with FF, and then do this, and then add 30 compared to 39. So let's do that. Let's do that. Let's AND AL with FF. So we'll AND with this. We'll add, is adding 30? So we'll add 30 to get the number value by default. I think there's a much better way to do this, but I'm not doing it. So this is probably not going to look right. Let me just make these. I know these are 1 byte and this is 1 byte, but if I do like 00 hex. If I make all these 2, that would probably make more sense. Especially when I'm looking at this. That would make more sense. Move that down there. So here, yeah, we're ANDing both of these, so we're getting both the values. If these are all 1s, so 1 and 1 is 1, 0 and 1 is 0. So basically the 0s will stay 0, the 1s will stay 1. And the number will not change. That's all I'm doing with this. I'm adding 30. So maybe I shouldn't have ANDed. There's no reason to do it. But anyway, let's add 30. So compare AL with 39. Jump less than equal to whatever hex num. Otherwise, if it's less than, then it's hex. If it's greater than, it's A through F. If it is A through F, we need to add hexadecimal 7. Add 0x7. And then we can print again. Alright, and I need to do that like each time, so, which is not great. I could put a little hex converter here, or down at the bottom or something. Or move it into its own thing. Printing hex, I could have convert, I don't know, A to H, I guess this would be, or H to A, right? Hex to ASCII, that's what this would be. This is the main logic in. Let's just do a thing here. Let's call it hex to ASCII, and I'll undoubtedly change this later, but that's all right. Let's just do this here. So we'll call it, and then we'll have a return at the end. Assume hex digit in AL. All right, so that's what we're gonna do. We'll do what we did up here. Oh, I'm gonna have to get rid of all this crap. That's okay. That is okay. So this. Basically, I'm gonna move all of this. All right, we'll put it at the end. All the way down here. Hex to ASCII. Or well, let's do print hex is ASCII. There we go. That makes more sense, I think. Hex num. And that'll print it out to the screen. Hey-oh. Okay. Now if that is wrong, then we'll know when we run it. I'll do my testing then. Right now I'm just laying out the thought groundwork here. So let's call print hex as ASCII. And this will be starting sector. Or I'll put start sector number, I guess. Start sect number, which will basically be the same thing as this. But if I want to do something different with these later, for me it just helps me, you know, conceptualize it, visualize it better if I have them separated out like this. Starting sector number, and we'll follow it up with file size. Alright, and then it didn't save that, because why would it ever save it? I guess Alt-W only saves it once in the kill ring or whatever. Alright, then we'll print out the file size. I know that the white space isn't here, so it's going to be all jumbled together, which isn't great. I understand that. That's not really good. But then we'll do that, and that'll be, you know, a full entry has been printed. So we want to keep on printing these until we're done. So I guess after we do that, we want to print out, go back to the file name loop, right? And get rid of all these. Alright, so after we're done printing that, I'm going to, we'll move into 0xa, 10, we'll print a new line out between each one, and 10, okay, and then we'll jump back to file name loop, okay. Get the next entry here, file name loop. So, how do we know we're done? How do we know when it's over? We can jump back down to get program name if we're, you know, right, if we're done reading it. Which, if we're done reading it, will be... This maybe looks, well, I wouldn't say simpler, but it's more broken up. Maybe this is simpler now. I think it looks a little bit simpler. It's better. What we can do is compare if CX is not at 9. That's assuming this is all padded out. If we do this and it's 0... Then we go to check name. Well, I want it to be at least 1. That's not fair. If we do it and it's 0, let's jump equal to get program name. Let's assume we're done. We'll go to get program name down here. Alright, but if it's not 0, we want to print it out and increment and go back. Let's move stuff to begin with. Move AL. Yes, BX. Okay, and if we compare, we're gonna get the name. Do I need to keep, I'm trying to think of how to keep track. How do we keep track if we read in, you know, if there is a name? How do we know if there is a file name if we're at the end of this list, right? Or whatever. How do we know we're at the end? If the first character is a blank, if the first character is a 0, our CX is 0, that would be it, wouldn't it? Because that would mean we don't have anything in there. So we can keep this like this, but yeah, we'll just go back. We'll get rid of this. What am I thinking? We'll jump name here. Check name. So let's compare it to 0 first. Aha. 0. I'm not XORing on each iteration though, am I? I'm incrementing here. Where am I resetting CX? I'm not. Let's reset it here for the next name. Reset counter for next file name. Alright, there we go. And then when it jumps back up, it'll start counting again. Aha, so if we haven't counted any, no name. Then we can jump equal. Aha, see, there we go. Genius. This is not going to symbol, it's going to be terrible. Anyway. We don't need to do this here, I guess. Because then it'll just do this check again and again. And that'll be terrible. We don't want to do that. If I include the check here, I don't want to do that. Let's just... Oh. Check name loop. Easy peasy. Just add another label. Bam. Jump check name loop. There we go. After it's printed, the user can input the program to load. I do need to add white space between these, but we'll just do this right now. You know what I could do is store values and variables and use them later. That might be good. We might want to think about doing that. I have all these loaded basically into memory, but I have to search through this whole thing again. Should I start and make like an array of something of the names? And if it's not in the name array, then, you know, we don't go to the program because it's not there. Maybe that would be easier. I don't know. Not absolutely sure, but this should be a little bit easier because for the name, we just have to check the first up to 10, and if it's not null. And then the sector we already have at a certain offset into the table, into that entry. This is a little bit of work here though. Got ourselves a little bit of work here. Print the screen. So you know what? It might crash. That's okay. Let's see if this even works. It does not. That is okay. Add 07. Add 07 to what? I agree. Add it to what? Line 346? Or it's at the bottom. No, it's at the bottom. You're right. You're definitely right. Right here. Add AL. There we go. Ooh, invalid argument. It did not like all these bytes being defined. Why didn't you like it, friend? Why didn't you like it? Do I need to do this? Comma, not a period. And then do this. I don't like that being blue, but if that's what it takes, then we can do that. That is okay. There we go. That's all it was. That's all it was. Now let's see how much this fails to run. Probably a lot. All right, there is no white space between these. And it doesn't print them out. It does print out the heading though, that's good, but it's not printing out this stuff, which is not good, not great. It does take in my stuff, so it didn't print out anything. Weird, sector not found, nope, press any key. So that is odd. And it printed the new lines, so it must have gone there immediately. I'm doing jump, God, I'm such an idiot, oh my God. Such a fucking idiot, that's okay. That's okay. You know what? That just means it's time for me to sleep. That's all that means. That just means it's time for me to sleep. That's all that means. It's okay. We're doing all right. We're doing all right here. That is an easy beginner's mistake, and I am forever beginner. That's why it's amateur OS dev. It's not professional. There ain't nothing professional about this. Hey, look at that. I know it looks weird, but hey, look at that. Boot sect and bleh. Look, I'm printing names. I know it's not right, but we got something. And by Jove, by darn, something's better than nothing. It's looking pretty well. All right, let's get this same heading doohickey here. I'm gonna put above this. Let's do that. That's okay. We can also select text backwards. Oh yes, innovation. The finest in innovation. Print the heading out. Takes a while to load up though, but that's okay. Spam, look at this. All right, so boot sect, so bin needs to go over here. It also did not get the N, which is odd. Why would it not do that? I should print the first letter and then the second letter, and then third letter should be an N. 1, 2, 3, but it wasn't. See, it's not there. That's not good. All right, but you know, we changed the beginning part. We are gonna have to change this part too. So what I'm gonna do is put to-dos here so I remember. Ha! To-do! Change to accommodate. That's not how you spell it, but I don't really care. New file table layout. To-do! Add white space. Alright, sounds good to me. Alright, I'm gonna leave here and I will splice in where I get back to this. So yeah, I'll see you then. Okay, let's get back to this. So, par for the course in programming, you take a good night, well, a decent night's sleep, and then look at the same thing the next day and figure out your issues within like 5 minutes. That's normally how this works. But anyway, what I'm gonna do here, instead of padding out with nulls, nulls would be fine, but they make things annoying right now. So what I'm gonna do instead is pad out to 10 bytes with spaces, just in case they're not there. So bootsect 8 characters long for bootsect. We're gonna pad out to 10 with spaces. And we'll just do this. Instead of 4 zeros, 4 spaces. This just makes it easier to deal with right now. I might change it later, but I mean, right now, this just, yeah, we don't have to deal with checking a null here to go to check name. We just have to basically compare if CX is at 9, and if it's not, then, you know, we're not really going to deal with it. We're just going to go here, compare 9. However, if AL is 0, then yeah, after we reset CX. If the first character of this is 0, we're at the end and we can go. Else, we can see if CX is 9. Which is what we're doing here, check name loop. Let me just do it here instead. So compare CX to 9. If so, we're gonna jump to file extension or whatever this is down here. If it's not 9, then we'll do what we did, increment, and go back up until we reach 9, and then the spaces will be printed out and we'll be fine. That should be all right. Check name loop, we don't need to do this anymore because we're not doing this. Haha. And CX does start at 0 up here, so it'll go, you know, increments after we check, and we print it out, then we'll increment. So I think that'll be okay. If not, then we'll work on it. Then we print out the file extension. So what I'm going to do first is to get things to line up under our header we got down here. We got like spaces between these. I'm going to print some spaces between, you know, the values, so that lines up under here. And to be able to do that, oh, this is also messed up too, and I'm going to fix this. Let me just put a placeholder here. I'm going to put it into CX for a counter. CX number of spaces to screen. And we'll put a thing here. I'll call it like print blanks loop or something. But okay, the reason we don't need this, first off, we don't need this. Don't need to add. We can use this though, add and compare. This jumps less than equal, so the reason it wasn't printing anything before partly is because I didn't print anything out unless it was A through F. So let's print out by default and then not do, well, not do that. Do that. Print out by default. Okay, so that's really all we had to do. Is actually print out the character no matter what. That should fix that. Also, we need to do this first off, so that everything's set up, although I think it's still set from before we call this. I don't want this open. So print blanks loop, I want to print out CX number of spaces, I guess. I need like 2 spaces before the file extension. If something's pad out to 10, we still need about 2 spaces before we hit this to line up with the header. So what I'm going to do there is move into CX2, and then we're going to call print blanks loop, or blank loop, whatever I called it. So it'll print out, well, we're going to say it'll print out 2 blanks. And then we'll print out the extension here. Directory entry, we'll have to print out some more blanks. I don't know, I don't remember how many worked for this. Maybe like 9, 8 or 9, something like that. We'll do the same thing. Print out more blanks and do that. Sector number, I don't remember what looks good for this. We'll just say 6, I don't know. We'll change it. So that's fine, we'll change it. And then we got the file size. I'll do another 6. And we'll mess with it as needed. Call print blanks loop. Alright. Let's go. Let's print blanks loop. So we moved the thing into CX. So I need to, we can compare CX to 0, I guess. See if we're done. If it is done, then we'll put end, we'll go to like end blanks loop. Otherwise, we're gonna move into AL, a space or a blank character, we're gonna print it to screen. And we'll be good. I don't need to keep moving this in, but this is just to say, hey, we're using teletype output, and we're printing a character to screen, and then we're gonna decrement CX. And then whenever we want to end, we'll have our end blanks loop, which is just going to return. I think that'll work and that'll be okay. All right, so we'll see what happens there. Let's see. Undefined symbol, check name. Aw, yeah, because we're not using it anymore, of course. So check name we're not doing anymore. When we're done, we can go to get program name because we're done printing. That's what we can do. Get program name. Hey, there we go. So now we have this, which is not good symbols. That's not good. This needs another space, it looks like, for the BI to move over. And we should be printing out 0xa and 0xd, but we're getting some issues there. So let's look at what that is doing. CX2, let's make this a 3. Print out one more. So where are we at here? So we print out the name, we print out the 3 extensions, and then it's being all weird on me. And we have these. I think these are messing up as well. I'm gonna change these back to just 1 byte. I'll be a lame-o. Change these back to just 1 byte instead of 2. Well, they should be 1, but you know what I mean. Just 1. Not that that'll change much, but it might change a whole lot. That does this. Okay, 3 still didn't move that. That's weird though. That's not moving over. We're still getting this issue here as well, which is not great. Oh, this isn't going back. Duh. Jump, print, blanks loop. It has to decrement after it does that. Well, that's something. That could change everything. Simple mistakes. Alright, this time I'm going to pass a Q. Pass that flag. As the window goes down over here. Okay, well it's not printing the in there, but that's okay. It's printing stuff almost in the right area, but also not. We're getting closer though. Alright, this can be a 2. 2. Am I incrementing BX before I do this? Well, I am. I'm doing B, and then I'm incrementing, right? And then this should be the I, and then I'm incrementing. That should be the N, but it's not. So why is it not? And then we move, we're not getting the next one though. So we're like taking the same character and moving it back in. We need to increment before this point. Okay, that makes sense. Increment BX. And then that should get the first character, which will be the B, and that should print the 3, BIN. Okay, so that can change some things. I like how this window keeps moving every single time. It's beautiful. Move it in the middle, please. All right. Hey, there we go. That looks slightly better. See, that's BI. Well, these aren't right, though. It did print the 2, and then it printed BI, but it did not print N. I don't really need this either, because it's already set up above. Let me see if I make that 0x0 what happens. Maybe it doesn't like reading the hex for some reason. I don't know. Well, we need to read a byte first, so that's not good. That's bad. We need to increment first. Alright, otherwise it was reading in garbage, so that could be part of the issue. I might not have saved my kernel either. No changes. Well, I did now, so. Oh, hey, there we go. That was the only issue. We had to increment. For some reason, reading it again did not work. If we did that, then this looks good. And I do need another space here. Dang it, I keep missing that. It keeps changing on me. But it looks like these numbers are correct, so that's good. Change this back to 3. I keep pressing R3 because I was doing... Sometimes I work in Vim, and then this is Emacs, and they're different. So that's why I'm pressing an R to replace, but this isn't evil mode or anything, so that's not working. That looks correct, but then this one down here needs to be like 8 or something. Alright, it's be 8. This one needs to be like, I don't know, like 12 or something. That needs to be a lot higher. So let's see what 12 does. So, and what I'm doing is going to match them up under the first column, and then I might change it to match them up under the last one, because that'll probably look better, but we'll start off by getting them lined up, and then making sure they're correct, and then we should be okay. So bin text bin, which is correct, 011, should be 2, that's correct, so we're starting in sector 1, we're going 1 sector in size, the next one will start at 2, going to 3, which means 2, 3, 4, so this should be actually 5. And then this should be 6. So I need to change that anyway. Let's change that. Because if we're counting the sector as 2 as part of the size, which is what we should be doing, it should be 5, and this should be 6. Alright, and this I can go back to doing H, because it looks like I'm comparing them right now. I don't know, we can work on lining stuff up later, making it look pretty. I just want it basically lined up under the first column right now so it can fix my OCD right quick. For the start sector, we need 1 more. This needs to be 9. We'll see about 13. Oh, it needs to be 14. Alright, oh well. You know, the important thing is that we got our 16 byte file table layout sort of, you know, fresh in our minds now that we're going to move towards, and we can print it out. And we'll have, you know, entries look like this. I want to make a thing. This is cut off. Let's fix that. But we have the entries. We're saying, you know, which number for this we have the entry at. We have the starting sector and file size. It's pretty good. That's all we need for a basic sort of CPM style, very early DOS maybe style file system. But it's definitely no FAT16 or anything. But that's okay. Why is this being cut off? That should be going up to 10, should it not? I'm incrementing after. So I thought that would be okay. We'll compare AL to 0, it's not. CX is not 9. So we're going to increment. We're going to print it out and then increment it. Print it, increment. So print. I guess it never gets to that point. Okay, well, we can move the check to after the increment. Then, if we want to do that. And that is fine. We'll see if that changes it. Because it might. Compare to 9. We're going to go extension, else we'll print the next character. Maybe I'm just putting the loop in the wrong place. It's usually something simple like that. But that's not right. Nope. I guess 9 is not high enough, which is weird. You figure it would be. Because 0 through 9. I'm counting 0, right? Because this starts at 0. So I figure this would be okay. Oh, I hate stupid faults in my logic. I feel like an idiot. That's alright. I did add white space, so I can get rid of this to do, so that's good. I don't know. I can change this to 10. This is fine. I can change this later. We'll see if that works. Oh, that changes everything. But this does get the ending right there. That's not good. 10 messes it all up, so 9 was the way to go. But it misses the end of the word. Which is what I thought. Increment CX. Increment BX. I don't need to jump equal file extension. Maybe that's ruining my day. Calculator. Hey, there we go. Okay, I changed something, obviously, because it works. And if I type it in, it doesn't go to it, because I still have to change that code. That's okay. So we got the print, and now we're 1 off, because we need to change the first one again. That is alright. We'll change this again to alright. So we got the file table to print. That's awesome. We got that fixed. I don't know whatever I changed here, but CX and then BX and then whatever, going back. Anyway, it works now. So after we go here, we say accommodate new file layout. I don't think that's how you spell accommodate, but that's how I spelled it. This should still be 0e from above. DI points to command string. We're moving 0 into length. That's okay. Program name loop. X out AX. Get the keystroke. H is 0, AL will be the character. BIOS tell type output, user pressed enter, that is all fine. Otherwise, we increment the byte and we store it. That's all still fine. Start search. Move it to the start, XOR BX. Okay. So this is where it's not fine. Alright, check next character. So we don't need to do this, because this is not relevant. Compare AL to null. If it's a null, then we're at the end of the file table. I don't really need to do all of this, but if we can make minimal changes and have it work, I'm okay with that for now. Program not found, that part still works. Found program does not work, I know that. Program not found, yeah. So let's change this stuff. Next sector number. I don't need to do this. All we need to do is read whatever part we're looking at, the starting sector. That's what we need to read. Instead of doing this and multiplying and stuff. Don't need to do that. I'm glad I knew how to do it, but don't need to do that. So not too many changes here. Sector not found. I didn't get that though. I got program not found message. I got like this, did not find. I was gonna say if they didn't type in the name right, then we could go to just the next byte here, or the next thing down, because I don't think it's gonna match. If they don't match the B in bootsec, then they're not gonna get bootsec, they'll get something else. So we might say you have to type in the file name correctly, or else we're just gonna check the next byte. Instead of incrementing bx here, we can increment bx by like, or we can add bx, add 16, right? 16 bytes? That should be right. I'm hoping that means 16 bytes. And instead of going 0, it'll be at 16. Right? Because this will be 0 to, this is 0 to 9, this will be 10, 11, 12, 13, 14, 15, this will be 16. So if we add 16 to 0, it should go to the next name, and so on and so forth. Maybe there's a better thing, you can just directly add a word or something, but I'm hoping this will work. So if the first letter doesn't match, it'll keep going, because it's not really going to matter. I guess. Yeah, that way it won't matter at that point. But if it's 0, we've gone through all the names, and we need to say, hey, we didn't find your program. I think that makes sense. But it's saying the program is not found when I run this, right? That's what it's saying. I put in CALCULATOR. The sector is not found. It is finding the program, so we're good to go on there. Okay, sector is not found. We're good to go with this stuff so far. So assuming they typed it all in right, we don't need to increment. We don't need to do this stuff. We just need to get whatever value this is at, the starting sector, and then go however many to read. But the starting sector is what we need here right now, and that is at bytes 14. So what we need to do is set bx to, you know, the 14th byte in the current entry. So how do we do that? This is fine. So really it's just this code we need to change before we load. We need to put the sector number into AL if we don't want to change this. Number of sectors to read, we also need to put into something. And we call this, okay. It should always be found. There shouldn't be an entry in here with a valid name and without a sector number. That's a failure of the program designer. So I should say we don't have to account for that. Then I won't have to do all this. All right. Let's do get sector number. Not checking that. We do want to eventually go to load the program though. Don't need that. All right. We shouldn't have a sector not found message really. So I'm gonna get rid of this against my better judgment. Delete. All right. So wherever DL is pointing, the next byte of the file table. So BX at this point, we need to get the sector number. Where are we going to found program? Right here. If the whole name matches. So BX would be at the end. It would be like here, right? Okay. So at this point it would be on whatever the first character of this is. So we'll have to add 1, 2, 3, 4 to wherever BX is at. So let's add BX4. So BX at this point should point to our hex number for the sector number. So move CL, whatever's in ESBX. Right, because CL will be, yeah, this thing, sector number to start reading at, all right. So then we have that. This system and 13. We don't need to do this anymore. We're still loading arbitrary location 8000. We're doing this. So what we also need to do is save though. DL will be 0. We need to save the number of sectors to read. Okay. So to get the number of sectors to read, we advanced one more byte to get the file size. So increment bx, and we're going to put this into DL, the byte at ESBX. All right, we're XORing AL, so we got to do stuff. So that's where DL is at. I'm moving DL to 0. Why am I moving DL 0 up here and then I'm doing it again? Is it because the N13 messes it up? Oh, because I'm doing that. Okay, well we cannot save it into DL then. We need to save it somewhere. Number of sectors to read. We want to put it into AL, but I need this to be like this. So I can move this message here. Put it there. Alright. I don't know what I just pressed. Doesn't matter. Alright, since I'm XORing it out, we don't need that. Reset the disk system. Oh, I'm XORing AL, not AX. Let's XOR AX. I can actually put this up here. I'll just put this here instead. That makes more sense. It's with the other stuff that's affecting it. Okay. So instead of DL, we need to save it somewhere. Maybe BL, although we move our stuff into here. Those are the only registers I have, dude. Unless I make like a area down there. So I gotta change this stuff. Okay. So we'll change this to BL right now. And before we mess with BX right here, we'll move into AL, BL. Alright. Number of sectors to read. And then we'll zero out BX for that. And then we don't need this. Okay. That's AL, AH, CH, DH, DL. And then CL is set up here. Sector number to start reading at. Load program. Technically don't need this label anymore. And I'm gonna put this stuff up here as well. Actually, I don't need this label here either. Alright. Let's move this around. I'll just move this around. Alright. So this should be okay. Then we'll call int 13 to read into memory. Starting at the starting sector, reading the file size, this number of sectors into memory. Then we jump not carry in case we have a success that's loaded. If there's not a success and the carry flag is set, then we have an error and we'll print out the error, go back. Otherwise, we're going to load our program here. Move the stack segments. I don't need to use FS or GS, I don't think, because I'm still doing 16-bit, but I'll leave them there anyway. So let's see if this works now. If we go here, calculator, hey, it loads it now. Congrats, congratulations. Bootsec does not have, well, it's not going to load. I mean, it found it, but it's not going to load anything, so I wonder what this is going to do. Load the boot sector again? No, just say program not loaded. Okay, that's okay. It's always interesting to find what will happen. Because I eventually want those things to work, but, you know, we got the file table working, we got programs to load, so that's good. The next thing I'm going to work on from here is making like a prompt thing, so like, we'll have a symbol like this or like this, and then the user can type in. We'll just have a prompt go on. Maybe I'll try to implement backspace as well, but I don't know. Delete just advances the cursor, but I'll try to make a prompt here. Sort of prompt program. But then after that, I make a basic prompt that shows back up. I think I'll get rid of the menu. I might have this heading line, but I'll get rid of this menu, and instead I'm gonna make these into like commands or whatever that we send to the prompt. So kind of like a shell, but not really. But I want to make stuff like ls or like a dir if you're familiar with DOS to list the directory content. So instead of the F here for file and program browser, I'll have a dir, which will go and do, I think it'll just be like an alias to F right now. But stuff like that, and I'll be able to hopefully like delete from this command line that we're gonna make. Have a delete command or something, maybe a rename, or a copy or a move command. I have stuff written down. What else did I want? Something like, not like cat, well, I guess like cat or type, but mostly just to print a file contents to screen by reading as ASCII bytes instead of as regular binary or hex code. bytes, and then maybe some other, commands in there, and then we'll go from there. But that'll be the next quick thing I'll try to work on. Semi quick thing, as these videos are like, when I record these, they're about an hour each, and then I have to splice them together and then pare them down, because I take forever working through things. But anyway, good news, man. Look at this. It looks slightly different, and we got stuff to work, and we're good. So we'll work from here. Yeah. Thanks for watching. See you on the next one.